Our next talk here is from Professor Songlin Fei. He's a professor and Dean's Chair of Remote Sensing in the Department of Forestry and Natural Resources. He also leads the Integrated Digital Forestry Initiative, IDIF, that's using digital technology to manage urban and rural forests in the US. And his work is also part of one of the Purdue University's Next Moves initiatives. So I'm really pleased to welcome Dr. Songlin Fei for his talk on digital twinning of forest ecosystems.
All right, thank you. This is the remote. Can we move the top bar? Oh, okay. Well, very nice to be here and talk about digital forestry related stuff. So I'm gonna go through this multiple projects that is directly related to digital forestry. And I first might have to make a disclaimer over here. Whatever I presented here is not necessarily all my work. I was part of some, but some of them not. And I have pictures of people who are directly involved for each of these projects. Okay, well, so let's get started. And first off, when we started digital forestry, someone says, well, you're going to create digital twin? I'm like, what are you talking about? I have no idea, right? And so I've been educated and I learned through the last several years about this. Now I'm standing here thinking, well, it's a great idea actually called digital twin. And because in the digital world, you can do all the things that you wanted without really harm the actual systems. And you can do a lot of meaningful things to manipulate, to simulate, and so on. And so I intentionally did not include any work at the end. I did not include any of Dan Aliaga's work because he's going to talk more about this in detail, but I'm going to give you a flavor of different projects that is ongoing. So we'll start with this. What about us? Well, the Digital Center for the Digital Forestry. Well, we are a group of faculty members that really in a natural grassroots collaboration that started 3 or 4 years ago. A bunch of us are, thinking about how we can do cross-disciplinary work together and to answer some of the very fundamental questions in forestry. And so currently we have in a group about 25 PIs from 6 colleges across campus. And very great guys, and some of them are already here, sitting here, like Jen is actually part of the digital forestry. Again, I already mentioned it, Daniel back there is part of digital forestry. But we are focusing on what we call 4 M's. The one is that we are doing a lot of measurement, how we can do this automatically without touching, without manually doing this and doing this in a speedy and effective way. And I'll show some of the examples. The second area that we focus on is called monitoring. This is either being monitoring the hazard, monitoring of disease outbreaks and other disturbances. So that's another area. And then the third area that is how we can apply these knowledges directly to the stakeholders, the management side of the things to make it a data-driven, science-driven management. And then the last thing is obviously, by the end of the day, it's about the people. And one thing that we need to focus on is how to educate our next generation, right? And so we are doing what's called the digital mindset. And we're doing this in a way of understanding what our undergrad needs, what our grad student needs, and we work together to create this. We already have a digital natural resources minor, and we're working towards a professional master's degree on this. So that's in a nutshell about what digital forestry is. And again, we have about 50 grad students and postdocs and 25-ish faculty members and a bunch of great staff. And one of it is sitting right over here. Benny Gala is helping us with some of the data pipeline and so on. All right. So I'm very briefly going to give you some of the tools that we're working with in terms of some version of digital twinning of different platforms and different technologies that we use. Here's the one that is mainly led by a mechanical engineering professor here about smartphone-based twinning, right? And the example I'm showing here is that how you use some simple common tool that's in your pocket, which is an iPhone or an Android phone, that you can do this with a measurement and recognition. So for example, here is that we now can utilize this to do a millimeter level of accuracy of measurement of an object. And here, particularly in forestry, we're looking at the diameter of things. But also we are training a AI model, building a database with the automatic, species recognition. And then along that, we'll continue work with stuff like how many board feet that in terms of timber and lumber that has and what economic value or carbon and associated with. So that's one area. Here's another area that is, doing this twinning under the idea about using some more drone technology, right? Can you do under canopy studies about, and here's just a quick movie of showing you an understory drone that going through, and then you're immediately seeing this depth map, and you can start mapping and understanding the overall forest. And if you in a clear environment that is less of hazardous environment, then you can do this kind of work relatively easily. Again, it's under canopy, but you don't have the thick growth underneath, so you'll be stopped by. This drone technology already have the automatic avoidance, but it's still in a limited capacity. So another area is by another professor in the civil engineering. Can we do something photogrammetry based, digitization and twinning? And so here's an example about using simple images, and you stitch them together. And then you would create a digital twin like this, right? You do a photogrammetry, you reconstruct the 3D point cloud, you put this into this, and then you segment it and you put it back into, here's the skeleton of the trees, and then you individualize it. Once you individualize it, you're able to, put the other features back into this, and you do measurement about. And so these are probably going to have much a wide application, given like what Dr. Jin was talking about a moment ago, RGB drone-based. A lot of people can afford that, and you can do a lot of the cover large areas that are associated with. I'm going to move on to another area that we'll spend a little bit more time about is what we call the LiDAR-based approach. So there was a question earlier about what about other sensors. And so here is an area that we spend a lot of time on about a LiDAR-based approach. And now we have multiple examples for you. And anyone know where this is at? And I'm going to play a movie for you, and you're probably quickly going to notice where this is at. And so, well, this is in just outside over here. That's the Memorial Mall. That you currently we kind of tricked you, and this is you're almost like a bird and flying through, but this is actually not. Data was acquired by a backpack system. And you see these kind of blue line over here, these are the lines actually people walking, because the light is hitting the people's back of the head. So you kind of, visually you can see it. So the data acquisition for this Memorial Mall I'm showing here is about, 15 minutes. You can get the whole Memorial Mall mapped out very nicely. So what we do with this, well, that's currently it's just a pretty picture, right? And can you use something about it? Well, so far the technology give you is, I call them, you back in the years, the days that we have these digital cameras, you get a lot of pretty digital pictures, but the pictures does not only the human can interpret, oh, here's my pet in there, here's a dog, here's a cat, but it does not directly automatically tells you information. So what we're doing is that we are trying to learn from these pretty pictures to convert it to information, to knowledge, to action. So that's the part that I'm going to spend a little time to talk about. So here's an example of a forest plantation. And again, plantations are much more organized compared to natural forests. But even we call it an organized, it's not really. But what we do is that we turn this point cloud, which is what you've seen, like the same thing as the Memorial Mall. And this is actually an aerial data acquisition. Data is acquired about 400 feet or 100 meters above the canopy. And then we collect the data. And now what you're seeing is that actually we can put every single individual stems mapped out. Not only that, we can do segmentation. You see each tree is being colored by different colors and showing we can do segmentation. Not only that, we can do segmentations of, and we can start measuring them. So we now are able to measure every single individual stems in the computer by thousands and tens of thousands at a time with accuracy of at centimeter level. Right? I'm going to give you another example of a natural forest, which is how many of you know Martell Forest? Some of you know. If you've never been there, try it. It's I call it a gem that you have in this soy and cornfield that is 7 miles west of the campus, is 470 acres, has 7 miles of trail that you can walk and have 100 feet cliff. I'm advertising this. Take advantage. It's open to the public. Very beautiful area. But here's the data that is acquired at Martell Forest. Okay? This is in 30 minutes of data acquisition and acquire about 40 acres of land. And we can do measurement of every single individual of this. And besides the ability of measure this, and I'll have a more detailed map showing this, this can put into the Envision Center. We can walk through that. We can put goggles on and we can simulate real stuff. And so there's a lot of unlimited information that you can, opportunities that you can explore about. But what I'm talking about here next is then how you can turn these pretty pictures into something useful and into move step forward. So here's an example of point cloud on the left, segmentation using AI methods. Then you not only tell individual trees, but components of trees. Like the one on the right, far right, is that can tell which parties have the woody materials that can be used either as timber or other purpose, right? And so the segmentation, if you look at the individual stems, you know what? We have a very good AI is to a degree now that our human eyes can see it, they can see it, right? Segmentation a couple of days ago now, Meta released something called segment anything, all right? You can segment anything, right? But this is an AI showing not tell you segmentation, but train how much clear wood that you would have. So what you end up with is that from a pretty picture that you have like this, and you can train an AI on it, and you can start segmenting it, and then it tells you all the stuff. Like here, now we can start seeing that we can separate the canopy. So the yellowish part is the canopy. We can harmlessly take them away because we're not really cutting them. In the digital world, we can cut it as much we want it. Well, we can cut it. Now you can see the on the ground downward debris, which might be fire hazard, but the green stuff is the most valuable stuff that you're looking for, which is the timber or carbon or fiber. And each of the individual stems are mapped to a centimeter level accuracy. We can measure individual stems to the centimeter level accuracy. So before you said, if you're harvesting this, before the tractor or the fill bunch or the trucks are being moved over, we can tell you how many truckloads are going to be, how many days you can have going to be there. So there's a lot of good stuff that you can do with it. And here's a different way of looking at that. This is by another lab that is going on, but it's the same technology, same reality is that you can do this by many, many acres, and you can do it beautifully and fastly. This is in this mission, this is the whole 460 acres data acquisition in a day, okay? And we are talking about hundreds of thousands of stems that, and here is the reason you see clumps of this is we have ground data that we can verify and showing the accuracies about. And then after you have this, then you can do reconstruction, you can do simulation about it from the original tree, you scan it, you can do, again, from scan to construct, and then you can put the results back in. And this is something that some of you might familiar, this is Dr. Bedrich's work, and you can do simulations about whether how they respond to wind, how they respond to a storm, and whatever these other parameters that you would be thinking. And you can and then you can make this information learned and stored, and then you later on you can regenerate and you can create your own forest and using this method, and so on and so forth. And the last thing that I want to highlight here is that we are also working on, so far most of them are about the point cloud and geometry. Can we do more about it and do species identification? For some people, they don't care for the production purposes, and the black walnut will worth way more than a sycamore tree, right? A nice veneer quality black walnut, you will pay $3,000 to get that tree, or $30,000, depending on higher quality. Or if you have a sycamore, you will need to pay people $300 or $3,000 to take it away from you. So there's that much of differences. So we are spending a lot of energy on this as well. And so far, this is, and again, Dan might be cover some of that as well. We are doing satellite-based species recognition as well. With that, that will be my, so I used all my 20 minutes, but if you want to learn more, there are more information can be found on this website. Yeah.
Obligated to ask a computation question.
Yes.
So with all this kind of work, how does computing help? Maybe you can help us understand some of the challenges, where we can help.
Yeah, so computing is always a challenge, right? And so to begin with, we subscribed multiple of these RCAC computing nodes, and to speed up some of the processes. And we realizing that, guess what? These are not sufficient for handle. So we start doing two approaches at the moment, and wish we can learn more from you guys how we can do it better. So one is that, Dan is sitting in the back. We have built our own clusters, which he's now wanting 100 terabytes of more space on that. We're building multiple of these clusters that GPU based. And we are also working with companies like AWS, and so they are willing to give us free credit to begin with, and we're experimenting that. But soon, we're going to be out of capacity. I mean, I'm constantly being pressured of, can we have another 20 terabytes? Can we have another 100 terabytes? These are the common questions. The question back to you is that, whether it's hardware, whether it's computing, if we can have more and the support and the streamline, especially students, I think this is the number one bottleneck is this. Students are always fun, they are bottlenecked by not able to get into the cluster. Like every time we bought something or rented something, it's already been occupied. So how we can make this more sustainable? That's a big issue for us. Because, and then also the technological support, like I have a postdoc telling me, well, my thing's running on the supercluster for now 20 hours now. It's still running, I don't know. But is that really optimized? Is that best utilizing the parallel computing then? I mean, these are the questions that we could be benefited by some of the support that you guys might be able to provide.
Thanks. I think we have time for one more question.
Yeah.
So I was interested to know about the imaging velocity and how close they are to real-time segmentation and imaging of these products and agriculture lands.
So you mean velocity in terms of how fast we can process them, or?
Yeah, from sending a drone out to the forest, from that point to being able to get this digital representation of your forest and being able to perform
Yeah.
some analytics on it.
Very good question. So at the moment, we are doing this as a research scale. We're not at the production scale yet. So what that means is that, again, I said data acquisition normally it takes about 30 minutes to 40 minutes or to an hour, depends on how fast, how big in the area. And then once the data come back in, like it can be take days or it can be take 30 minutes if we get the right people to ask, like Benny Gawley in the back now helped us to build the pipeline. Now all you need to do is a click. And the point cloud so far is, get into and get aligned, right? And then the next thing is that once you have that, the training of AI segmentation or training itself will take a long time. But if you're able to now streamline this, make it in a professional environment, that's from multiple days to multiple minutes. Right? So I cannot give you a clear timeline in terms of how much it takes. It can be, the answer is can be days of work if you are not know what you're doing, or not saying not what you're doing. It's most of the process are manual. Could it be a couple of minutes if this is not automated? And what we're aiming towards is that we'll be making a cloud computing environment. So all you need to do is submit the data and then send it to the cloud and streamline the process. So we are interested in make this sort of commercially available.
Great. Well, thanks again, Songlin. Let's thank the speaker. I think that's all the time we have for questions.